Hi, I am Janik Barmir. I'm a researcher and consultant. I'm dealing with fluid mechanics, compressible flow, die casting, the economy of manufacturing, and many other topics. I have written 4 popular books that have been used from NASA teaching all the way to people who don't know any material or any background for self-study. Today I will be talking about stability, and I will be talking about stability of cylindrical body. This is a cylindrical body, and what I will try to do is emulate different conditions and mostly the density change. So I will do the density change by filling it up with water. You can be noticed that it's not exactly the density of the whole cylinder will be changed, but it's kind of emulation. The center of gravity actually will be moving. It will not be in the middle of the height, but it will be somewhere in the middle of the height of the water inside this cylinder. And that case is actually more restricted case than my theory or model, and we're going to check it out how this thing works. The first thing we can notice that on solid surface, if we having the body, it's very stable. We cannot even move it at all. If we want to move it, we can get it to the next point. It will move to a different location. And if it's in this location, I can change the density and I can fill it up all the way to the top, and you can see that it's stable. But what happens if I put it in water? To see this thing, let's look what happened. If it's empty, there's nothing in the cylinder, and I will put it inside the water, and we can see that it is stable. It will oscillate around a certain point, with certain kind of frequency that we will discuss later on in future video, but it's stable. Now, what do you think will happen if I will add more water? Well, the center of gravity will move down, so would it make it more stable or not? Let's see. I add some more water, and it's about, you can see 50% of the water there. It's full, about 50%. And if I put it inside the cylinder, it will be flipping. 45 degrees. It is stable, but not stable in the location that we wanted. We want to have it vertical stable, and we get it turn around stability. So what is going on? Would we add more water, it will make it less stable? It will turn totally, or it will become stable again? So it's almost full. You can see that it's almost full by seeing the surface tension there. And we're going to fill it up to the top, and it's too much water. Let's reduce a little bit. Hey, this is stable. What happened? Well, in order to understand why suddenly it's stable under certain condition and in other condition it's not stable, let's look to the theory that I developed. This is the diagram that results from my model that I developed. First, let's explain what this diagram showing. This diagram showing as x-coordinate the ratio of the density of the solid, meaning the density of the floating body, to the ratio to the liquid. And the y-coordinate showing the ratio of the radius of the cylinder to the height of the cylinder. According to this model, when you have very low density, the body will be stable. In this case, it's about 0.5. That's about 0.5 of the height. And we will go from 0.5, so we have a stable zone, unstable zone, and if you fill it up again, we see that it's stable again. In fact, there is some area that if it's very, very wide, like 1, I mean if this cylinder was very, very wide, that will be stable no matter what. And in a future video, I will demonstrate this effect. So if we put a body on liquid, it can be stable, but it will be stable in different angle. In solid, we will have stability only in one angle, in one condition, or in condition that they are perpendicular to the surface. For example, the body is stable like this, it's stable like that, and it's stable like this. So there is 6 surfaces that the body can be stable. In the liquid, it will be stable, but not in the condition that we might expect it. It might be in some angle. Well, that's about for this point that we want to discuss, the stability of surfaces or body on liquid or cylindrical surfaces. Thank you very much for watching the video, and I hope that you want to watch the next video and all the other demonstrations that we prepare. Thank you and have a nice day.